All right, good morning, everybody, and welcome again. I'm Kevin Gobert from Valparaiso University. I'm a member of the Unidata Users Committee, and we'll be introducing speakers today. And so I'm excited to get this workshop kicked off here with Johnny Lin, who is a senior lecturer and director of undergraduate computing education in the Computing and Software Systems Division of the University of Washington, Bothell, and still an affiliate professor of physics and engineering at North Park University. He's authored a book based on his AMS short course titled A Hands-On Introduction to Using Python in the Atmospheric and Oceanic Sciences, and teaches an online introductory course on Python for atmospheric and oceanic sciences clients, and is also the current president of the American Scientific Affiliation. Today he's going to talk about Python in the atmospheric sciences, using it to do science the way we've always done it, as well as new ways we can use it to help do more and better science. Let's welcome him.
Thanks so much for having me here. Thanks, Kevin, for the intro. And I hope everyone is fueled with caffeine and fruit and pastries and ready to go. The sort of three things we'll be doing this morning. I'll quickly talk about myself, and you'll see there's a reason why. It does actually kind of relate to our time together. There'll be sort of some quick comments with regards to what is and why Python. And then I want to try to spend more time on the working session. And the three things we'll be doing here, we'll be looking at some basic data analysis, line plots, as well as writing a file. Now, one of the things I want to say from the get-go is that what I want to do sort of in my time is kind of a more basic look at Python and using Python for tasks that we do in the atmospheric sciences. The hope is that it'll be kind of a spin-up for folks for whom Python is more on the new side, and we'll set things up for all the really cool presentations and packages that will be going on later in the day today. And so just to give you kind of a heads up about that. Now, this is just a little bit about me. I'm not going to go sort of in detail about it, but the main thing that I want to point out in the education stuff that I've done, and as well as the kind of work that I'm involved with, is the one thing you'll see that is not listed there is computer science. So I teach in the computer science department now. I think it's one of the most hilarious things that I have this position, and I still can't believe that they actually hired me. But it's the way that things turned out in terms of my career. All this is just to say that if you think you have had difficulties with using computers and programming, I know that my problems are much, much worse than your problems. I will just tell you that from the get-go. So if you are looking for someone to commiserate with you and to bang the laptop with you in frustration, then I am that guy. Okay, and I could bore you with stories about my own travails, but that's the main thing that I wanted to share with regards to my own background. Okay, what I'd like you to do now is to turn and meet your neighbors, the folks who are sitting right next to you. Of course, get to introduce yourself to them, and also ask them what they do. But what I'd like you to also do is to share with one another your own comfortability with Python based on one of these four categories. So that you've heard of it. Second, that if you've done more than heard of it, you can write your own functions, to share that. And third, that if you think writing classes is something that you're comfortable with. And finally, if you give Guido all of his best ideas, Guido is the guy who actually wrote the language, and so if you're number 4, you will be so bored with my talk. It is not even funny. Okay, so take a couple minutes just to introduce yourself to the folks sitting next to you.
Oh, you're the brains behind the. Well, what I do a lot. I'm not the brains college. I do a lot of work on the city website. Yeah, I mean. For a little college student, you ever heard of this? Is like making it to the NCAA. It is. It's very much on I expected that, but I thought you would. Good job. Yeah, anyway, great work, you guys. What's the team there? Just you? No, yeah. Team there are two full-time faculty. Started this program over Dr. Victor Jensen came on board a couple years ago. Evan Anderson is our webmaster. Myself, I've been affiliated with the program for a number of years. Thanks a bunch of people. Lovely. Big. And there's maybe half a dozen others. Yeah, I've always wondered who was behind all that. Anyway, you use Python? Just started to, yeah. Yeah, okay. Heard of it, me too. Yeah. I've downloaded it several times, several versions, and they collide. I took this beginning short course, so I didn't even know what a tuple Yeah, good. Yeah. Just get a little bit. I get to say, my kids can spend a little bit of a challenge. Problem where I hope that is the he is too. We don't all assume everybody else is starting to be. Yeah.
And we're on 2.4.3 at the center, and you can't do classes.
Oh, really?
Yes. There is no, it's not available
Interesting.
in the version that
Python at ECDC?
it's about 10 years old.
It's like, well, that's going to change.
When's that going to change?
When I install my stuff for OISST,
Oh, okay.
there's no way I'm going to, I cannot do it without classes.
Yeah, I mean, we've been doing, the stuff we've been doing, rewriting stuff in Python. There's all sorts of great new functionality that's not available.
Yeah, no, that's going to change.
Yeah, I had something I need. I really was like, I really would like to make this a class. And it was like,
Throw out all this.
a little pile of functions.
Yeah.
Hopefully later,
Or you
when
might as well just say, no, we're not doing Python. I mean, really.
we
That's
got.
ridiculous.
Yep.
Say, nope, sorry.
I can't believe
We're
that.
moving up.
I can't believe how old it is, and that's what they think is reasonable for us. to
Okay.
do. But anyway.
We'll come back in like a minute.
Doing it already.
So
Because
Yeah.
and it's 279.
In a container, yes. You're in a container though, right?
It's,
And it might just be.
it's a
it might
three-tier
just,
architecture.
Yeah, that's yeah. It might
Base
just
install.
yeah, and it might just be.
okay,
If you could
so
try and Python on the command
I
line.
hope you all had a good chance to meet your neighbors. I also hope that as you did, that you've found folks who are on all of these, or at least the first three of these different categories in terms of comfortability with Python. My hope is that, especially for those of you who've had extensive experience in the language, that during the working session this morning, that you met folks who are more at the beginning of the learning curve, and that you'll be able to help them along. And for those of you who are at the beginning of the curve, hopefully that some of your neighbors are folks that you'll be able to ask questions to also as we go and do the working session together too. It again probably goes without saying that most of the stuff I'll be talking about will probably be of more interest to folks in Category 1 and Category 2. It'll probably be things that for folks in Category 3 that maybe not so of interest. Okay, in terms of slides, they're already on the data server. Unfortunately, however, like all good speakers, you have to do some last-minute changes the night before, and so that's what I did. And if you want the more recent version, they're here. The main substantive difference between this version and the one that's on the data servers, I added 2 additional examples in case we had more time to get to them, and I also left out the comics because of copyright issues. Okay, so
Back up to that.
I'm sorry. Okay, so this URL is just my name with a hyphen, temp, and then unidata15.zip. Okay. So if you wanted those, you're welcome to.
Where else did you think these were available to us right now?
Where else? They should be at the.
Not on the GitHub.
How do I get these? I don't know how to get them. Do folks know? If you,
Mm-hmm. And the workshop page is? I found a variety of things from there.
so I'll just leave this on just really quickly for a little bit longer if folks want to get a copy of it.
There's some
Okay. So what is Python? Obviously, today's session is on Python, and I'm sure everyone who's here has heard of it. And so this description is probably something fairly familiar. One way you could think of Python is in terms of its structure. It's what would be called a multi-paradigm language. You can use it as a scripting language, as a replacement for shell. You could also use it as a procedural or a sort of a subroutine focused language like Fortran 77 was, or well, I mean, is, I guess. We still use it a bunch, maybe more than we should. But it's also a fully natively object-oriented language. And in fact, if you use it as an object-oriented language, you'll be able to leverage a lot of its capabilities. I didn't include this here, but it also can be used as in the functional paradigm, as a functional language, which is really nice for multi-processing parallel applications. You could think of it in terms of whether it's compiled or not. And in that case, Python is an interpreted language. That is to say, it's not something that requires you to compile it. Rather, it runs through an interpreter like IDL or MATLAB. So you just type in something that you want it to do, and it'll automatically do that without having to go through a compiling linking process instead. It's also what would be called loosely or dynamically typed, so you don't have to declare a variable before you use it. In terms of data structures, it has a very robust built-in set, and you also have freedom to define additional structures as you would want. And in terms of array syntax, it's very similar to MATLAB, IDL, and Fortran 90, and in the sense that you don't have to use loops. And we'll be talking about a number of these. And finally, it's a language that is platform independent, so it'll run on basically any major operating system that exists, and it's open source and free. Free both in terms of no cost, as well as free in terms of being able to innovate on it. If you looked at its popularity, well, where does Python rank? So the TIOB Programming Community Index, here's the one from this month, puts it at number 6. So these ratings essentially it's a popularity index, and it's based upon Google searches and other search engine searches. In contrast, other languages that we're interested, in terms of our field, for instance, MATLAB is something that's used quite a bit in our community, or in the natural sciences in general. But in terms of its popularity, it's down, something on the factor of like 2 to 3 less popular. So it's ranked number 15. Fortran is down at number 27. And IDL, Maple, and Mathematica are all in the undifferentiated group between 51 and 100. Well, what does that mean? Well, as we'll talk about in just a little bit, what it means is that if you choose a language, or you're using a language that only you and your community uses, and nobody else uses it, then basically all the innovations that everyone else provides is closed to you. It's something that is not accessible to you. And one of the neat things about Python is that it both functions as a language for the use of scientists and mathematicians to do scientific work, and it allows us to do that work in ways that we're really comfortable with, just like MATLAB and IDL, but at the same time is also used by folks doing Google back back-end stuff, people who are doing web services, database work. And we can therefore use the innovations that come from those communities for our own nefarious purposes. Okay? So in terms of advantages, let me just list off a whole number of them. First, it has a very concise but natural syntax, and so the clarity of programs is improved. At least that's I would highly, highly agree with that particular claim. There's a saying that Python is executable pseudocode. Am I coming in and out on this? No? Okay. Yeah, no? Okay. Okay, then I'll leave it here. Python is executable pseudocode, while Perl is executable line noise. And while I'm not anti-Perl, but I think that first statement certainly is very, very true. Python reads like as much as a programming language can read as regular written English, it reads that way. Additionally, the fact that you don't have to compile or declare variables makes development a lot easier. And like I said before, the OO makes code less brittle. Now, of course, some folks would like to have the idea of programmers as this sort of rarefied breed of people who do things that are impenetrable to others, as this particular comic expresses. One of the early Dilberts. But that's one of the things that Python, one of the neat things about Python. Some other advantages, like I mentioned before, has a built-in set of data structures that are very, very powerful, dictionaries being one of them. Namespace management. Well, what do I mean by that? Well, let's think about Fortran. In Fortran, if you want to use other libraries, you link it with those libraries. But if you have a library that has, let's say, a sign function, and another library you're linking to that has a sign function, there's a collision that can occur between those two similar, exactly named functions when you link them together, or at the same time, with the particular program that you're running. The way that Python is structured, all libraries are essentially imported into their own private namespace. And so by default, you can't collide functions that are of the same name with one another. You can get around that if you want. This is not something that's advisable, but the default mechanism in the language is to prevent you from doing this. In addition, Python has these very, very tight interconnects with compiled languages. So if you do want to run Fortran, if you do want to run C out from the Python level, as well as other languages, you very much can do so. And this particular XKCD is sort of a classic with regards to Python. And in fact, you can type import anti-gravity, and it will work. If you go to the code, it doesn't do a whole lot, but oops, sorry, but it is there. Okay, and then finally, like I said before, the neat thing about the Python ecosystem is you're able to make use of all these other resources that other people have created, both those in industry as well as those in the sciences. Now, there are disadvantages. It does run much slower than compiled code, but there are tools to overcome this. One of the sort of classic ways of doing it is really performance-intensive stuff. You farm out to C or you farm out to Fortran, and all the kind of less intensive stuff, a lot of the user interface stuff, you leave at the Python level or the analysis you might want to do. In the past, the sort of collection of scientific libraries compared to Fortran is relatively sparse. This is still the case, but there are a lot of changes in that front too. So what I'd like to do now is just give a few examples of some things that folks have done using Python. So here are some examples of some classic visualization from with regards to atmospheric science type things. Atmospheric science type visualizations. These were all created by Pingo, made by the folks over here over at NCAR. And we have here a classic SKUT and a mediogram. Here's an example of a particular package called WXMap2 that essentially is, so it's all written in Python, but you can see it's a sort of standard interface for visualizing and delivering weather maps of NWP results. Here's another example from, of a package called VizTrails. What we have here, this portion, is salinity data in the Columbia River estuary. And this part describes basically the entire VizTrails package is geared to describe allow you to track provenance as you do analysis. Provenance is essentially, when we're doing analysis, creating graphs in our research. Well, you have some data, and then you do some things with the data, and you see a plot. It's like, well, that's not exactly what I want to look for. And then you do some sort of subsetting with some other portion of the data. Maybe you add different axes, or you look at different ranges. Each one of those steps, if you wanted to go back and recreate your work, well, if you didn't keep track of what you did, then you wouldn't know exactly how to recreate it. So provenance is essentially the keeping track of what you did to get the result that you finally displayed, or that you're finally interested in. And so if you have software that keeps track of that provenance, you can essentially rewind to a point that you're interested in and branch off from there. Now, this particular example, I don't know how clear it is. I just love this example, and even though it's like years old now, I always talk about it. So Bill Noon at the Northeast Regional Climate Center presented this slide, and it talks about basically the use of Python in the Applied Climate Information System that they've created. And what I want to point out here is that in the ACIS, what they do is they ingest data from a whole bunch of different sources. They distribute that data to other regional climate centers, and they store this data. Then they generate tables, summaries, and graphs that are then served out to end users who are not other regional climate centers. So people like the general public or other folks who might be interested in some sort of processed version of the data. What the red parts here show are all the Python packages that are used as part of each of those steps. So for the data ingest, Twisted is a web services package in Python. For the distribution, CyclePG2 and CH5PY are packages that address each one of those different data formats. And here are a whole variety of Python packages that, well, R is a language, but you can call R from the Python level that are used for the analysis and the visualization. Think to how you would do this if you weren't using Python. You probably have some shell scripts to do file management. Apache will do your web servicing of whatever files you want to actually be serviced on the web. Probably have some scripts in MATLAB, maybe some scripts in IDL, and then, you might also have some Fortran and analytics that you're also doing on the side. So how do these things communicate to each other? Well, they only communicate to each other. Each of these steps of your workflow only communicate through files. And that's limiting both in terms of development as well as the kind of information that you can pass back and forth. Every time you create something, let's say in Fortran, you write it to a file. Then you have to write something that will read that file. And if you decide, I forgot there's another piece of metadata that I should have included, you go back to Fortran, add that new field into your output file, rerun your Fortran program, and then add that new field to be read in at your IDL or MATLAB level, take that in, and then now you visualize. So that entire process is what a file-based multi-tool workflow requires. But in Python, you do this all in one environment. Everything is accessible in memory to one another. And so instead of playing with 5 different tools, you only have one. And I think that this particular capability is what, at least from my perspective, is the thing that makes Python so incredibly useful in terms of atmospheric sciences work, because it makes us a lot more efficient, and then the work that we do is less prone to error. So the conclusions that I have for this portion, the talk portion, is that Python is flexible, powerful, open, and free. The structures and tools it provides really enable more robust programs to be written. And ultimately, I think it results in basically better work to be done. And it's done more easily, and it's done at less cost, both in terms of time and money. Just thinking back to my grad student days, all the time I spent doing stuff in front of the computer and things not working. Well, if you can get a better tool, then it results in just so much less frustration. Now, this may not be your only view, but I had to just include this still version. So maybe we can, if you want, you can spend more time and more money in terms of writing your software. Okay. Any questions about just this kind of quick overview? No? Okay. So why don't we go on into the working session? And again, in this particular working session, my goal is not to introduce all the syntax. We only have 35 minutes. But rather what I'd like to do is to look at 3 basic but typical atmospheric sciences tasks: data analysis, line plotting, and file writing. And I want, through this little quick look, to give a taste of how Python works, what its syntax is. And then the sessions later today will go into much more complexity and detail and show some of the real power that Python has. Okay. Just to let you know, there's a file. If you downloaded it from Ramada, it's not sitting in a subdirectory, if I recall, called examples.py. If you download it from my website, it's in code/examples.py. Basically, all the main examples are there. And I also created this sort of synthetic data set, just a bunch of calculations just for the use of that data. Okay. So the first topic then, basic data analysis. The 3 things that I'd like us to hopefully take from this is just to describe the looping syntax used in Python, to have a quick introduction of creating and using arrays, and then to contrast looping and array syntax for accessing arrays. Okay, so what I'd like you to do is to turn to your neighbor and to share with them your answer to this question. So let's pretend you have 3 4-dimensional arrays in Python. Python arrays are called NumPy arrays. So if you see NumPy arrays as being the way it's described, that just means a Python array. So these 3 arrays are U, V, and W, the different components for wind. And each of these arrays are dimension time, level, lat, and long. Okay. You have 100 time slices, 20 levels, 10 latitude locations, 15 longitude locations. So how would you go about calculating the wind speed at each location in time? Okay. If Python is something that you're comfortable with, how would you write this in Python? If you're new to the language, do this in pseudocode or in Fortran or in MATLAB or whatever language that you would prefer to. Okay? So take a minute or 2 to think about how you would do this, and then share your answer with your neighbor.
You know what I'm saying? That's my problem.
Where am I supposed to write before I do this? Set to 66.
I think, yeah.
But I got his point is that that is exactly right.
I mean, this is good, right? Just like a bracket. You should be.
Okay, so you say what you've got here is how far is it moving this way.
You
that
tell
way,
us
this way.
Okay.
So you have the speed in each component direction.
Okay.
So what's the absolute total speed in the direction of the motion?
Yeah.
Okay.
So it's just been decomposed into 3 orthogonal.
So I'm a computer programmer. If you give me the formula, I can figure out
Let's
how
what
to
is on the
program it.
formula.
I don't have the formula.
For each individual thing, it could be the square root of the sum of the squares.
The square root of the sum of the squares? Okay, so now I can do it. That's what I'm saying. But there's,
Well, that gets in. I mean, that depends on whether you're a meteorologist. As a physicist, I'm saying my wind speed is my speed. As a meteorologist, I may say my wind speed is only because now we're getting into flavor differences. I bet you could do this. It'd just be, just whether it's 2 or 3 dimensions.
Without it. But assuming,
there it is. The square root of the sum of the squares. Yeah, I
Okay,
remember when I
folks
went
want more
through this
time?
tutorial,
I see a whole bunch of green,
but using the Python
green Post-its up.
was like, okay,
More time, less time?
but then learning, oh,
Huh? Green, I think is, everyone's always green.
we were green
But
before.
everyone's wants to talk more
Residual green.
with your neighbor or not? Yes?
when you're done.
Okay, well, I'll take no red Post-its as being a.
And green.
And just FYI, if during the course of this morning you see me, I'm kind of like looking down at you or something like that, okay? The reason is not that I'm like kind of being all hoity-toity and just like, oh my word, I can't believe you're asking that question or whatever. It's that I recently graduated bifocals, and I'm having just the hardest time like trying to make sure that I'm looking in the right place so that I can like see you all, as opposed to like, oh my word, everyone's all blurry, right? So just to let you know, if I'm nodding in this really funny way, that's really what's going on. Okay, so I'll take it that we'll chat about this together. So this is one way of doing it, and this is a way of doing this using loops in Python. And so in this particular solution, instead of me saying something, why don't we do this? Okay, so this part where it says discuss with your neighbor, there's a couple questions. What do you think the import statement does, as well as all these particular questions? See what your neighbor says. So based on this code, so even if you've never seen Python before in your life, just from looking at what this says, how would you answer these questions? So what do you think the import statement does? What does the period do? What's zeros, SQRT? What's data type, D type, indentations, et cetera? I'm going to assume that most folks have a copy of this so that the questions you can look at, and so I can keep this up on the screen. But if that's not the case and you don't have a copy of the slides, just discuss with your neighbor line by line. What do you think each of those lines of this code does? So let's take a couple minutes to do that.
Oh, no, I had it open. There it is. I was going to go talk with my neighbor over here who doesn't program at all.
The sum of the yes, as a single line. Yeah, fine. And then import.
I know the network.
So it initializes. Yeah.
So modules have to already kind of be on your computer. They're not loaded into Python. Right.
You can do it in modern Fortran is ancient. A lot of people are still writing Fortran in 69.
There's a lot of these. So I'm displaying all the modules as computer has available to us here in a second. So I have all of these numpies in here somewhere. But it's not until I import numpy that I'll be able to use it in my script.
Oh, and you do have anti-gravity. Okay, there you go. Yeah. Yeah.
import it? What do we get? Yeah, right. How do you explore one? Okay, so
Yeah. So in Python, you have this concept of
yeah. How do you find out what it is? You go Google, or you don't like load it.
so what you say, okay, import.
Yeah, I mean, import just flows when it's as is, you can rename it and say for shorter. Yeah, some of these are really long.
So that you don't have to write every single one.
Yeah, it helps.
So,
Well, remember what I hate about it.
I mean, of course, I hear what everybody
It's much easier when I use it.
Yeah, in indentation.
Like we have 11 variables in there. You get this heap. That's you import the formatting of help module so that helps.
The nice thing is it's really
I'm
hard
not
to
sure I've ever used
see if you don't have
Yeah.
throw it into a shared object like
In some way that it's just.
I also think NumPy is random.
Oh, I see. You're right. I think this is in range.
CDI files that we've got
For
into
completeness,
give a seamlessly
power
space, profile.
but I think in this
Got it all.
So I've done this for like,
The third part of it is, it's just like a 5-line C function.
it's all a lot of ways. So I have 115 plus 1.
Yeah.
Just to say, do we want to change brackets?
Okay. Why don't we come back together? So let me just make a few points in terms of what that particular example illustrates about Python syntax. So the first thing that we see is that the way that you import a library or make use of a package or a module of other routines is to use the import statement. And the import statement basically says, if you say import the name of that package, then you are able to make use of that package. Now, if you say import some package name as, and then some other name, like in this case, import numpy as np, np now becomes an alias for that package. So if you want to use the zeros function in that, then you say np.zeros. So the second thing we see is that that period after the module name says that the item that follows is a member of that module. The zeros function is then a member of the np module. So zeros and sqrt are going to be functions that are part of the numpy package. The zeros function you probably found created the zero-filled array, and the dtype input parameter, which was set to the string f, and string you can see is set off by paired quotes, means a floating point. Create a floating point array filled with zeros. Block statements, you probably noticed also, are set off by indentation. And one of the key things is this indentation does not have any end statements. So there's no if, end if, or do, end do that is paired. Rather, the indentation itself is what delineates the level of that, or the block of that particular statement. So the looping syntax we saw is basically in this form. If you say for I in list of items, the variable I is set in turn to each one of the items in that list called list of items. So this is different than Java. This is different than Fortran, in which the general way that we go through a loop is you have some sort of integer, and you have that integer be between certain bounds, and then that number loops through. Anything that can be found in this list of items, I will take the value of. So in this case, we would go through, I would be set to 0, 1, 2, 3, et cetera, all the way through 9. This happens to be the exact same thing as range 10, because range is a function that when you give it one argument, it'll produce a list of that number of elements starting from 0 and incrementing by 1. Range 10 then produces a list that's n elements long, and then in that way, it actually works very well as an index for an array. The other thing we see, too, syntactically is that in Python, arrays are indexed with 0 as the first element, and the last element is of index n minus 1, where n is the number of elements in that dimension. And if you want to specify the elements in an array, you use the square braces. The line continuation character is the backslash. And finally, the way that Python's arrays are indexed is the fastest varying element is, or dimension is on the farthest right-hand side, and then the slowest is on the left. That's why the lon is on the right side, and then it goes lat, then levels, then time. In contrast with Fortran, which is the exact reverse. It goes lon, then lat, and then so on. Okay? This Python, in this way, follows C syntax in terms of memory allocation of array elements. Okay, so, okay, we don't have time for this, so we're going to go on. Okay, here's a second solution, though, that we can give for the exact same problem. And in this particular solution, instead of looping through all those different levels with for loops and doing calculations element-wise, there's only a single function that we need to define here. Oops. So let me describe this solution in some ways. So first of all, one of the neat things about arrays, NumPy arrays, is that by default, they work with array syntax. So like Fortran 90, like IDL, if you take two arrays, here in this case u, and then v squared, w squared, and you add them together, when you're adding them together, you're doing so element-wise. And that's done automatically regardless of the number of dimensions that are in the array. And then when you take the square root of all this, it also is done element-wise. So the result that's created, wind that's created, is of whatever the number of dimensions and size for each dimension, the shape of each array for the u, v, and w. Okay? So the first thing is that in array syntax, you don't have to do any of this separating out in terms of for loops. Secondly, this looping that's done implicitly is done at the C level, so it's very, very fast in comparison to doing it explicitly using for loops. And then finally, this particular solution works for u, v, and w of any shape, of any rank. And this line of code doesn't have to change at all. You notice, too, that wind, you don't have to like pre-declare. You don't have to like create that array first. The array is automatically created, again, because Python is dynamically typed, by the output, by the return value of this square root function. Okay, let's do look at a second example. So let's assume we have the same values, u, v, w. And let's assume that the total wind speed wind has already been calculated. Now, what I want, the problem is now to change u, v, w, and wind so that the components and wind speed are all set to 0 at locations where the total wind magnitude is less than 0.1 meters per second. So we assume maybe that there's an instrumental noise and that all the values that are less than 0.1 are really only identically equal to 0. Okay? So how would you do this? Share that with your neighbor. How would you solve this problem?
Oh, I see. It's like in just one structure.
Yeah.
I think you might be able to do that too.
Yes, it is.
Yeah, usually you can like the brackets on it.
Clear
You can specify that
Oh yeah, there's a very nice way to
where
what you do is you do you write a conditional. Yeah. Essentially, in the array, or you
the way you calculate
calculate
where
Oh, yeah. Right. Where would go in and zap it to make a mass?
plug that into the
yeah. So you put that condition, and then if you say
basically say
the
again, it's broad. But again, what it's really doing is it's actually making an array. Basically, Python arrays.
ARMS radar communication. ARMS stands for something. It's a DOE.
When you do the square, you can actually do it just reading a shape file for this because you want to do multiples. You'd say equal to the result.
And there's also something called array displays.
And then you can say using additional square bracket index. If you put that
Displays radar data. But it uses IR also.
and so right.
Yeah.
But I mean, the naive way is to iterate over each.
Art views on reconstruction.
Okay, why don't we come back? So let me first give a solution using loops. What I'd like you to do is you'll see again there are these questions discussed with your neighbor. What does shape refer to? If statement do? Oops. Okay. Wait a second. Sorry. Object versions text. Okay. Why don't you take just a minute to talk with your neighbor about that? Given this solution, what does shape refer to and what does the if statement do?
Yeah. And shape shapes an array.
Yeah. So
And it's
when isn't an array, but it's not an array. It's like an object.
I use tab and I never really
More metadata associated with it. It's not just like the raw data associated. It has more functions that you can execute on. You can do like when that max, and it will give you a max and things like that. So, but in this case,
and it has to be for, or it just has to be some object.
yeah. Actually, it's part of it's
multiple
Programming practice going to help you correct.
many dimensions.
it is. You can think of it as separate.
It's pretty much
It's like
but
Okay, so why don't we come back? So what do we see from this? So before we talk about this on the next slide, again, I want to just point out that the syntax here for range, in the past, for the I index, we said range of 100. But here, we're saying win.shape square bracket 0. So what is all that about? Okay, so what does this illustrate? So the first thing that illustrates is that variables in Python are actually not variables in the sense of Fortran variables. Variables in Fortran we usually think of as they hold values. But variables in Python are actually what are called objects. And objects, in addition to holding values, they can hold multiple kinds of values, multiple pieces of data, as well as hold functions or methods that can act on that data. In the case of wind, the wind array has a particular piece of data called shape, basically a piece of metadata about that array. And shape gives you essentially the shape of that array. So in this case, shape is equivalent to what's called a one-dimensional list or tuple. That is to say, essentially a vector that is equal to 100, 100, 20, 10, 15. That is to say the number of time elements, the number of levels, the number of latitude elements, and the number of elements that are in the longitude axis. Thus, when we say here shape 0, it means the number of elements in that of the time dimension. This is the number of elements of the levels dimension, and so on. Okay. The period then, what that essentially shows, in a similar way to how when you import a module or a package like NumPy, and then you want to refer to a function that's connected to that package, you say np.zeros. If you want to refer to a piece of data an attribute of the array that's attached to the wind object, you say wind dot and then shape in this particular case. If you wanted to use a method that's attached to it, you would say the name of the object dot the name of the method and then the calling parentheses like any other function. If statements are the branching construct and look and behave as you would expect. Now, if we were to do this using array syntax instead of the if statements, you could do it in this way. So you can see it's a bit more concise, but let me sort of describe what's going on. There's a function in NumPy called where, and there's two calling signatures, but the one I'm describing here takes three particular elements. The first one is a condition. The second one is the value to set in the result if the condition is true. And the third one is the value to set in the result if the condition is false. So wind less than 0.1. Wind is a, how many dimensions is wind? It's a 4-dimensional array. So it's not a scalar, but is a 4-dimensional array that we've already pre-calculated. So when you say wind less than 0.1, what is the result of that? How many dimensions does that have? Okay, it doesn't have 1 dimension. It has 4 dimensions. So the result of wind less than 0.1 is itself a 4-dimensional array of the same shape as wind, but the values of each of those elements are now true or false, depending upon whether the condition was true or false. So this is what I mean by condition. This entire thing here is an array of the same shape as wind, and it says, and each element in that resulting the result of this less than operation is either true or false, depending upon whether that corresponding element in wind is less than 0.1. So the where function then will essentially construct another array that is the same shape as wind. It will be empty. Then it will look at the corresponding element of this condition, and if it is true, it will put the value 0 into that location. If it is false, that is to say wind is not less than 0.1, then it will put the corresponding element of u into that same location. Again, wind, u, and the result, which will overwrite the value of u, are all 4-dimensional arrays. So this entire function goes to each element of u, each wind calculation, asks is it less than 0.1, and if it is less than 0.1, it will put a 0 for the corresponding element of the result, and then the value of u if that's not the case. You do this for v, and then with w, and then finally with wind also. Okay. Now, and so this particular discussion kind of goes into more detail of what I just was saying. Okay. So the you can see that the array syntax and functions that allow you to do testing that are part of the NumPy array package are very, very powerful in terms of enabling you to write very quick tests with very little, requiring very little code, and it also executes fairly fast. Now, this particular exercise I'll leave for you to do if you wish. I want to try and get to the last two topics. So the second topic I wanted to mention was basic line plots. And here, the two things I want to describe is to quickly introduce the matplotlib package for creating XY plots, and then secondly, to describe array slicing. So again, here's our example. We have the UVW arrays, dimensioned, or the shape thereof, and then wind has already been calculated. So let's say you want to plot the average total wind speed versus time index. And the average, you want it to be over all latitude and longitude values at a given time, but over only the first 5 values of levels, the first 5 levels. Okay? What would you do? How would you do this? Okay. Share your answer with your neighbor. again, you don't have to use code. Just even conceptually in pseudocode
Yeah, so
is totally fine. But I just want to get us sort of thinking about what would be the steps that we would use in order to do this problem.
so since you
How would you want this plotted? What kind of chart? How would you want this plotted, like a line graph or?
group per
So you're averaging the entire domain basically, and then you're averaging all of the
First, yeah, he's tending to kind of the first five methods on the array objects approach.
So basically one value.
The functions right now. Like he's been doing numpy.
Gotcha.
Yeah. Square root and stuff. It goes, you can run it into I have no
Other ways to do that using arrays
like you first need to group per level,
all
and then remove everything but the first five, and then once you have those, each level
just a global
you
approach
obtain
for
the
accessing the same
and then
method.
you basically
so you would grab 5 lines, right? One per level, or
Okay, so it does actually cascade down that way. Yeah, here basically you identify the instead of having written those out, you can put those all here. Do the mean. And then of course you get well, it's a linear, it's just a 2D plot.
oh yes, because you have a variable that it's flat. Yeah, so you
Or
would
1D
think,
plot, however you want to think about
you
that.
would say it's similar like where level
creating a new average.
Okay. Sorry to cut our discussion a little short. I want to try and stay on time. So let's just take a look at this particular solution. Okay, so what I'm going to do is just going to flash this. If you could like put this on your own laptop, then then I'll walk through sort of the solution, the sort of what this illustrates about Python syntax. Okay, so the first thing is that matplotlib's plotting suite function based interface is in a submodule called pyplot. So if we say import matplotlib.pyplot as plot or PLT, this PLT becomes an abbreviation for that. So every time we say PLT dot something, we're calling functions that come from the matplotlib suite. If you want to slice a part of a dimension, the syntax in Python is lower colon upper, and where lower and upper are the indexes for the lower part of the range and upper part of the range. But the lower one is inclusive, and the upper one is exclusive. So this particular slicing syntax here, 0:5, takes the first 5 levels, 0, 1, 2, 3, and 4. It doesn't include the index 5 level. When you have a colon by itself, it means all those elements. So since this is latitude and longitude, this takes all those elements, the first 5 levels, and then just the ith wind, time, basically the time slice. And that subarray now is being fed into the average function, and you save the result of that, which will be a single value for the wind at that time slice. Okay? The arange function is like range, but it'll create an array rather than a list. And that's a subtle difference, but I want to explain it. And then the last thing I wanted to mention here is when you want to plot it, all you have to do is you say the x vector, the y vector. So this is just like MATLAB, the x vector and the y vector, and that's it for the plot. This part in matplotlib, this third argument, using the string O dash dash makes it give me a open circle marker and a dash line. Okay. These two are fairly self-explanatory, and at the end of it in matplotlib you have to say show, and it will show the particular figure. That way, if you have a whole lot of things that you are doing to make that figure and is kind of computationally expensive to do the rendering, you can save the rendering at the very end after everything's all done and that will save you time. Okay. If you wanted to save it, that's not in this example, but the savefig function in matplotlib pyplot will save it then to a file. Okay. Here's a little try it out. We won't have time to do. And then the final thing, I'm not going to be able to talk about this much, but I want to just describe that in terms of dealing with files, the idea of, in Python, of a file is you think of a file as an object also. And so in contrast with Fortran, where an open statement will connect basically a logical unit number to a file, and then your read and your writes are all using that logical unit number to say whether you want to read from that file or write to that file. In Python, the way you do that is through a file object. So when I use an open statement, this thing, this variable, this object, as far as the Python interpreter is concerned, is your file and has associated with it functions or methods, for instance, the write function or method, that you can use to write to that file or read from the file. And then it also has a method called close, which allows you to close the file. Okay, so that's just the one thing I wanted to mention with regards to file objects. Okay, okay, so final conclusions then. Again, sorry for kind of the rushedness of things. But the sort of take-home I wanted to mention was just that array syntax makes Python code faster and more flexible. The import gives you access to libraries in this protected namespace. Objects have these two characteristics to them. They have data associated with them, attributes, and also things you can do to that data. That is functions, which are called methods. My book, if you're interested, is here. There's the full version is online for free if you want the full version. I help run a mailing list for folks who are interested in Python and the atmospheric sciences. And I just want to thank the guys who did all the postings last week. Last week was a really, really active week. And I was just, which isn't usually the case, but I thought that was so cool that there's more stuff about NetCDF and X-ray, et cetera, than I ever knew existed. So I know some of the folks posting are here, and I want to say thank you all to that. Okay? I also want to thank Rob and Brian just also for the discussions prior to this. And that's all I have. I guess it's time for break, but the one thing I would like you to do, on one of your Post-its, write down on a green Post-it one thing that you took from this morning, and on the red Post-it, one thing that you still have a question about. You know, it could have been something we just didn't cover. It could be something that we did cover and is really confusing. But if you could do that in 30 seconds, like it doesn't have to be very long, and then take your break. Unless, is there anything else I need to say? Or?
No, but you can fill out the evaluation from the workshop side on the morning presentation as well to get the data.
Thanks, appreciate it.